Okay, so we're doing section 3.6, perpendiculars and distance. So here's basically what they're trying to get you to learn in this lesson. Let's say I had a, let's do this in a different color. Let's say I had a line. It doesn't have to be horizontal like this. It could be, oh, you know what I forgot to do? All right, so this should sound a little bit better to you. All right, where were we? We got a line right here, okay? The line could keep going. It could be a line segment, could be a ray. It really doesn't matter, okay? I'll just make it look like a line segment, but we'll call it a line. Now, here's what they're trying to get you to understand. They're trying to get you to understand what does it mean to what does it mean to find the distance between a point and a line? All right, and you say, well, you know, I don't know, what would it be? If I asked you, if I'm at this point, I said, how far is it from that point to that line right there? Would you like measure to there? Would you measure to there? Say it. Straight down, okay? But I don't want you to say straight down. I know exactly what you're thinking when you say straight down. Exactly. But if I say straight down, really, think of a geometric word. So this would be what? It'd be perpendicular, wouldn't it? Okay? And that's the key. Really, that right there is basically sums up this lesson. All right, is just understanding what it means to find the distance between a point and a line. All right, it's just the perpendicular distance. You follow me? This would be the distance. Because if I didn't specify that it was a certain way, I mean, you could have all kinds of distances, couldn't you? You could have a distance here, distance here, distance here, all that kind of stuff. In fact, here's another word that they use sometimes, and we're going to use this in another chapter. In the honors class, we're in that chapter right now, but I'll just throw this out to you. Sometimes we call it an altitude. And some of the honors kids are kind of making fun of me because I drew a picture, and my pictures are pretty lame, all right? Because I am no artist whatsoever. That's an airplane. Isn't that cool looking? That's an airplane right there, believe it or not. Now, anybody flown on like a commercial airline, right? The guy gets up there, the pilot gets on there, and he talks to you, right? Usually, like, and then you hear him, he's like, "Oh, thanks for flying Hamrick Airways," and then they say, "Oh, today we're going to be traveling to Florida. It's nice and sunny, 75 degrees, and blah blah blah." And what does he usually tell you? Does anybody know? Altitude. The altitude. Okay. Why I want to know how many feet I'm flying up in the air and I'm going to die from if the plane crashes, I don't know, okay? But he likes to tell you how high up in the air you are. So he usually says what? He says, oh, we'll be cruising at an altitude of 30,000 feet or whatever the thing's going to do. What is that altitude? What is that 30,000 or 20,000 or whatever thousand feet? Is it from like where you're going? Is it from where you came from? It's what? Let's not say straight down. Perpendicular, right, okay? That's the altitude right there. It's perpendicular to the ground. So when you're up in the plane and the guy says we're cruising at an altitude, that means the perpendicular distance from where the plane is to where the ground is. Does it make sense? Okay, that's why they use the word altitude. It's a geometry word, and it's also an ordinary everyday word, right, that people use all the time about how high something is, okay? Everybody with me on that? All right, that's altitude. People use altitude for other things too, like Denver is the mile-high city. Why do they call it the mile-high city? It's a mile high, right? From what, though? From sea level, that's right. Perpendicular, okay? It's not like stretch the distance down the mountain, is it? It's what? Let's not say straight. Perpendicular, right. So if you had a line that went perpendicular, right, down to where the sea would be, that's the altitude, okay? In fact, I had a senior trip at my other school. We went to Colorado, and we went to the Rockies game. And there's actually a row, I don't know, has anybody ever been there? Rockies Stadium? There's a row of seats around the top. All the seats are black except for one row, and they're purple. What do you think the significance of that purple row is? It's 1 mile high. Does anybody know how many feet that is? 5,280. Good. Yeah, that's something that you learn in school, isn't it? 5,280 feet. And they're very proud of that. They have that everywhere. They even have the Capitol building. And like on one of the steps, maybe about halfway up to the Capitol building, they have a little plaque right there. And they said, this is officially 5,280 feet. Okay? And they call it the Mile High Stadium. Okay, that's enough of altitude. Okay? That's more altitude than you probably thought you ever needed. We could also do a line like this. It doesn't have to be like horizontal like that. You could have a line like this. and then have some point out like right here. And if I ask you to draw, if I ask you to construct or draw an altitude from this point, or if I asked to say what is the distance from this point to this line, what would it be? Would it be to the end point? Would it be to this end point? It would be what?
Perpendicular.
It'd be perpendicular. Now, I have to kind of eyeball it a little bit. That would be perpendicular, about right there. So if I asked you to draw the distance, it would be from this point perpendicular to the line. Everybody with me on that? Okay. Now, that's good enough, but what are we going to be doing? We're going to be using triangles. Okay, so let's draw a triangle. And what I want you to do is find the distance from one point on the triangle to one of the sides. Just draw it kind of looking like this. It could be any. I'm going to draw a couple different ones, all right, just to show you. But we'll just start with this one. We'll call it triangle ABC. And here's what they're going to ask you to do. They're going to say, or actually not find, I think they're going to say construct or draw. Let's use the word construct. That's what they mean. Okay, they mean construct or draw the distance from, let's say, point A to, let's say, line segment BC. All right, this is the kind of stuff they're going to ask you to do. It's very, very simple. The explanation of all this takes 10 times as long as you actually doing it. All right, and it's very easy. There's really no math involved. So we're starting where? From point A. So we're starting there, and we have to show or draw a line that represents the distance from point A to what? To line BC. So what do? We start at A, and we go perpendicular. Good. We go perpendicular to BC. Now, if that's all I did right there, would you get that answer right if that's all I did? Why not? You don't know what? If it's perpendicular, right? You don't know that that's 90 degrees, do you? Because you don't have the box. You may look at it and say, well, it sure looks like it's 90 degrees. Is that good enough in geometry? No. You have to know. All right? So, right there.
Doesn't matter what side.
Doesn't matter what side the box goes on. Nope. Good question. Does not matter which side the box goes on. And that would be it. That would be your answer. That yellow stuff right there, that line in that little box, that's your answer. I told you it'd be easy, didn't I?
So you had to do is draw a line?
That's it.
And the box.
And the box. Because look, I'm telling you, that right there means that it's a right angle, doesn't it? And it means it's perpendicular. If you don't have that box, is everybody listening to me? If you don't have that box, I'm marking it wrong. Because if you don't have the box, that's not telling me that it's perpendicular.
So what was so sophisticated about this lesson?
Nothing. I never said it was. I said there's something beyond it. If you want to watch what I do for the honors class, feel free to watch the video. But I'm making this a lot easier for you. Okay? Yeah, you're gonna have to find distances and all that kind of stuff. I made it a lot easier for you. That's not us. We still got one more. Watch this. Let's do another one. This one's a little bit trickier. Okay? This isn't quite as easy. Let's do an obtuse triangle. And let's say, we'll call it ABC again.
May I please ask Daniel Gadalka to come to the office? Thank you.
And watch this. I'm going to ask the same
Also ask
exact
Emerson to come to the
question.
office. Thank you.
Oh man. Now
What is that?
I copied and pasted and say I'm trying to grab. There we go. See, that's what's kind of cool about that. So I don't have to rewrite it since I already wrote it before. All right. All right, now this is a little bit different. Everybody watching? This is just a little bit different. We want to, it's still the same question from point A to line BC. So what do? We start at A and we go to BC. Is that perpendicular though? Look, this is what, everybody paying attention? Everybody looking up here? Because this is really important. Watch, I've had people do this. I've had people do this and then do like that. Just because you put the box there, it's got to look pretty close. Does that look anywhere close to 90 degrees? Obviously not, okay? So that you can't get away with that, all right? So how in the world am I going to go perpendicular? Look, if I go way out there, it's not perpendicular. I heard somebody said it. Extend the line. Extend BC. In fact, let's do that first. Let's take that BC and then extend it out. Did you see that?
We don't got copy and paste.
So look, if I start here, okay, all right. Need you up here now. Watch, I'm going to go from A, where? This is still line BC, isn't it? It's still line BC. Actually, I should put a line thing over top of it. It's not line segment, it's line BC. It keeps on going. Is that enough right there? I got to put the little right angle symbol. Okay, I got to put the little box. That's right there. So what do you have to do with this one? If it's obtuse, I would have to extend one of the sides. Make sure you see the extension. Sometimes books will put dotted lines to extend the line. I just grabbed it and just dragged it across, okay? You could put a dotted line if you want, or just drag it across and then make this go straight up and down so it's perpendicular to this and put the right angle. And that's all I'm asking you to do for this. I told you it was easy, didn't I?
Yes.
Yeah, very easy. That's pretty much it. That's pretty much it, okay? I'll give you a worksheet, and I bet you can probably finish it before you can get out of here, okay? All right, that's it.